In this video, we're going to be solving some exponential and logarithmic equations. Let's get started. Solve e to the negative x equals 5. Solution. To solve this for x, we have to basically get rid of the e. So in order to do that, what we'll do is we'll take the natural log of both sides like this. So we have e to the negative x equals 5. So we'll put a natural log here. And we'll also put one here. And the reason this works is whenever you have the natural log, e to the x, this is always equal to x. You can think of it as the natural log and the exponential basically canceling. This is true because they're inverse functions. So here, the ln and the e, basically these functions cancel, and you're left with minus x equals the natural log of the number 5. We're looking for x and we're almost done. So x is being basically multiplied by a negative 1. So we simply divide both sides by the negative 1. These go away. So we're left with x equals the natural log of 5 over negative 1. We can write that as negative natural log of 5. And so the answer is x equals negative natural log of 5. Solve 2 times the natural log of x equals 1. Solution. Because we have a single logarithm, the goal is to start by isolating this logarithm. Since it's being multiplied by 2, what we'll do is we will divide both sides by 2. So divide the left-hand side by 2, divide the right-hand side by 2. The 2's cancel, so we have the natural log of x equal to 1 over 2. We're trying to find x. We need to get rid of the natural log of x. There is a familiar formula that says if you have e to the natural log of x, this is equal to x. This is super useful. If you like, you can think of it as e and the natural log function basically canceling, and you're left with x. So we're just missing the e here, so we'll put an e here, and we'll put an e here. This is called exponentiating. So now these go away, so we're left with x equals e to the 1/2. And that would be the answer to this equation. Solve log base 2 of mx equals c for x. Solution. So we have to find x, but it's trapped inside this logarithm. So the goal is to get rid of the log. So in general, if you have b to the log base b of x, this is equal to x. So whenever these bases match, this b and this b, this goes away and you just get x. So here we have a base of 2. So I'll start by writing down the equation again. Log base 2 of mx equals c. And so to get rid of this log, because the base is 2, we have to put a 2 here as well. Then we'll put a 2 here. Then you see these go away because the bases are the same. So we get mx equals 2 to the c. We're looking for x, but it's being multiplied by m. So in order to find it, we'll just divide by m. Divide by m. We're left with x equals 2 to the c, all divided by m. And that would be the final answer. Solve 8 to the x equals 16 to the 1 minus x. Solution. Because we have an 8 and a 16, a very natural thing to try to do is to try to write both sides using the same base. There's a formula that says if you have b to the x equals b to the y, you can drop the b's and then you can set x equal to y. So we need to find out a number that we can use to represent both sides. So 4 doesn't quite work because I can't think of a power that we can raise the 4 to get 8. Also 8 doesn't work because of the 16. So I think 2 will work. 8 is 2 cubed, so we can write this as 2 cubed to the x, and that's equal to, and then the 16, you can write that as 2 to the 4th. And this is to the 1 minus x. Let's keep going. So properties of exponents say that we multiply here. So this is 3 times x. So this is 2 to the 3x. And then this is equal to, and then here you can multiply through by the 4. So this is 2. And it's really important to distribute. 4 times 1 is 4. 4 times negative x is negative 4x. Now we're in the situation where we can use this formula. So now you can drop the 2's. So we have 3x, and that's equal to 4 minus 4x. Okay, so now we have to solve for x. So let's see, maybe we can just add this 4x to both sides. So plus 4x, plus 4x. These cancel, so we have 7x, and that's equal to 4. Then just divide by 7, divide by 7. So we have x equals 4 over 7. And this would be the solution to this equation. Solve 3 times the log base 2 of x minus 1 plus the log base 2 of 4 equals 5. Solution. So when you first look at this problem, all kinds of thoughts might come to mind. One is maybe combining these logs, but then you realize you can't do that yet until you deal with the 3. But something else to notice here is that this expression here can actually be computed. When you look at this, you ask yourself, 2 to what power is 4? The answer is 2. So this is actually equal to 2, right? Because if you have the log base 2 of 4, and you call that, let's say, I don't know, y, then 2 to the y is equal to 4. And so y must be 2, right? Because 2 to what power is 4? 2. So this whole thing is 2. So let's go ahead and replace this with 2. So this is 3 log base 2 of x minus 1 plus 2 equals 5. And so now we only have one log. And so when we have a single log, the goal is to solve for the logarithm. So we'll subtract 2. So this is 3 log base 2 of x minus 1. And that's equal to 3. And so now we can just divide both sides by 3. So divide by 3, divide by 3. So we have log base 2 of x minus 1, and that's equal to 1. Okay, so now we're in a good place. Now we just have to get rid of this log. So there is a formula that says if you have b to the log base b of x, that is equal to x, right? These basically go away. So here we have a 2, so as the base. So what we'll do is we'll put a 2 here, and we'll put a 2 here. So these go away. So we get x minus 1, and that's equal to 2. Then we just add 1 to both sides, plus 1 plus 1. So x is equal to 3. And that would be the solution to this problem. Solve 5 to the x minus 3 equals 10. Solution. So the x is up here in the exponent. We somehow need to bring it down. So there are a few ways of doing this problem. So one way to do this is to think about this formula. You have log base b of b to the x, that's equal to x. Super powerful and super useful. Basically, when the bases are the same, the log goes away and you just get x. So here there's a 5. So we'll start by rewriting our equation. So 5 to the x minus 3, and that's equal to 10. Notice I left some room here. That's because I'm going to now take the log base 5 of both sides. And the reason I'm using 5 is because the base is 5. log base 5. You see, now we can use the formula because they match. So it basically cancels. So we're left with x minus 3 equals log base 5 of 10. We're almost done. We just have to solve for x. So now we'll add 3 to both sides. This leaves us with x equals log base 5 of 10 plus 3. And that would be the solution to this equation. Solve 25 to the x equals 125 to the 2 minus x. Solution. In this problem, we have an exponential equation, and it appears that maybe we can write both sides using the same base. That is really useful because if you ever have b to the x equals b to the y, what you can do is you can drop the bases and you just get x equals y. So super useful formula. So here we have 25 and 125. So we have to think about a base. Well, 25 is 5 squared. We can write it as 5 squared parentheses to the x. And 125 is 5 cubed. So we can write this as 5 cubed to the 2 minus x. Okay, properties of exponents say that we multiply here. So 2 times x is simply 2x. And then over here we have to be really careful. This is in parentheses, and so when we multiply these, we do have to distribute. So it's 3 times 2, which is 6, and then 3 times negative x, which is negative 3x. Some people like to show this extra step. I don't like to do it because I don't like it, but you can do it if you want to, and that's the step there. So then it's a little more clear here now that you're distributing, right? So 3 times 2 is 6, 3 times negative x is negative 3x. The 5s go away, right? We lose the bases, so we get 2x equals 6 minus 3x. And we're almost done now. We just have to solve for x. So let's get them all together on one side by adding 3x, and then adding 3x here as well. These go away. So 2x plus 3x is 5x, and this is equal to 6. Then the last thing to do maybe is just divide by 5. So divide by 5, divide by 5. So we get x equals 6 over 5. And that would be the solution to this equation. Solve the natural log of 2x plus 1 equals 2 minus the natural log of x. Solution. So in this problem, we have 2 logarithms and we have a number here. So the goal maybe is to get all the logarithms together on one side and combine them. So we'll start by adding a natural log of x to both sides of this equation like this. This is usually a good strategy in problems like this where you have like a number it's hanging out and you have a couple logs. Try to combine the logs together. So this is the natural log of 2x plus 1 plus the natural log of x, and that's equal to the number 2. Okay, so now we can combine these logarithms using a property. It's called the product rule for logs. If you have the natural log of a plus the natural log of b, that's equal to the natural log of a times b. This is called the product rule for logarithms. So here, this is our a and this is our b. So this is the natural log of, we have parentheses 2x plus 1 times and then x. Notice I inserted the parentheses here. That's because the 2x plus 1 is a single quantity, so it's important to have the parentheses. This whole piece here is your a, and that's equal to 2. So now we can get rid of the logs by recalling another very powerful formula. It says if we have e to the natural log of x, that's equal to x. This is super useful to know. This is basically true because the exponential function e to the x and the natural log of x are inverse functions. This is actually the composition of the two, and they undo each other. In other words, they cancel and you get x. So here we're missing the e, so we can just put it there, and these go away, and you're left with this whole piece here, which is the same thing as your x in the formula. So this is 2x plus 1 times x, and that's equal to e squared. Okay, let's keep going. So now what we're going to do is distribute this x. So this will be 2x squared plus x, right? X times 1 is x, and that's equal to e squared. And this is a quadratic equation. So whenever you have a quadratic equation like this, you do have to set it equal to 0 to try to solve it. That's usually a good idea. So we'll subtract the e squared from both sides. So we have 2x squared plus x minus e squared, and that's equal to 0. And this looks a little bit funky to me, so I think we should probably try to use the quadratic formula. So recall the quadratic formula says the formula is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So we just have to identify a, b, and c in this problem and plug them into our formula. So here a is going to be 2. That's this one here. B is the number in front of the x, so b is 1. And c is what's left over. It's right here. The general form of a quadratic equation is this, by the way: ax squared plus bx plus c equals 0. So we're basically just using matching. So a is 2, b is 1, and c is negative e squared. Okay, let's go ahead and plug everything in. So b is negative 1, so it'll just be negative 1 plus or minus the square root of b squared, so that's 1 squared, so it's 1, minus 4 times a, which is 2, times c, which is negative e squared. And it's all over 2a, so that's simply 2 times 2. So this is equal to negative 1 plus or minus the square root of 1, and this is plus, right? It's going to become a plus because we have two negatives, plus 8e squared. All right, and this is all over 4. So now the big question comes into play. Which one of these is going to be a correct answer? Well, notice that one of them will not work. If you look at the option with the minus, it's this one here. Square root 1 plus 8e squared over 4. And the reason this is not going to work is because this is less than 0. Right? This is negative, so the whole numerator is going to be negative. And if you go back to the original equation, we have a natural log of x here. So there's no way you can take the natural log of a negative number, right? So we have to throw that one out. So the only possible candidate for a solution in this problem is negative 1 plus the square root of 1 plus 8e squared over 4. And that would be the final answer. Solve the natural log of x plus 1 minus the natural log of x equals 2. Solution. So in this problem, we have two logarithms on one side and a number on the other. Because we have a minus sign here, a good idea might be to combine the logs. You can do that using what's called the quotient rule for logarithms. You have the natural log of a minus the natural log of b. That's equal to the natural log of a over b. So here, this is our a, and this is our b. So this is the natural log of a, which is x plus 1, over the natural log of b, which is x. And all of this is equal to 2. So that's called the quotient rule. So now we need to get rid of the log. So there's a formula that says if you have e to the ln x, you get x. So here we have an ln, so we're just missing the e. So what we'll do is we'll put it there, and we'll put it here. We'll exponentiate both sides. Then just like they go away in the formula, they go away here. So we have x plus 1 over x equals e squared. To solve for x now, we just simply have to clear the fraction. So I'll put an x here, and we'll put one here. So these cancel, so we have x plus 1 equals e squared times x. And we're looking for x, so it's a good idea to get them all on one side together. So maybe let's just go ahead and subtract x here, like this. So we have 1 equals e squared times x minus x. Now that we have them all together on one side, we can factor out an x. So we can put it here like this, and put a parentheses. And looks like we're missing an e squared, because x times e squared is x times e squared. And then minus 1, that's because x times minus 1 is minus x. This is being multiplied by e squared minus 1, so to solve for x, we'll simply divide both sides by e squared minus 1. So these cancel, so we're left with x equals 1 over e squared minus 1. This would be the solution to this equation. Solve the natural log of 5 minus 2x equals negative 3. Solution. So we have to get rid of the natural log. In order to do that, we're going to use a very powerful formula that says if you have e to the natural log of x, that's equal to x. Super useful to know and super useful to use it in problems like this. So we'll start by basically putting an e here and putting an e here. So we are exponentiating both sides. These go away, just like here in the formula, and we're left with x. So we have 5 minus 2x equals e to the negative 3. And we're looking for x, so we need to isolate it. So let's go ahead and subtract 5 from both sides. These go away. So we have minus 2x equals e to the negative 3 minus 5. X is being multiplied by negative 2. So now we'll just divide by negative 2. Divide by negative 2. These go away. So x is equal to, so it gets a little bit tricky here. So it's going to be this piece here over negative 2, like this, e to the negative 3 over negative 2, then minus 5 over negative 2. So x is equal to, so what we can do here is we can write it like this, negative 1/2 e to the negative 3, right? That's the same thing because the e is really over 1. And then this becomes a plus 5/2, just like that. And this would be the solution to this equation. Solve e to the 2x plus 3 minus 7 equals 0. Solution. In order to solve this problem, we have to first isolate the e. To do that, we'll start by adding 7 to both sides. So plus 7 plus 7. These cancel, so we have e to the 2x plus 3, and that's equal to 7. And now we need to find x, but x is up here in the exponent. So in order to bring it down, we're going to use a very powerful formula. Formula says if you have the natural log of e to the x, that's equal to x. This is extremely useful and super powerful. So what we'll do now is we'll put an ln on both sides. Basically, we're taking the natural log of both sides of this equation. So we have the natural log of e to the 2x plus 3 equals the natural log of 7. And so now we can invoke this formula. So we're just left with this piece here, right? That's the same as our x. So we're left with 2x plus 3 equals the natural log of 7. And now it's not too bad. We just have to solve for x, which is right here multiplied by the 2. So we'll start by subtracting the 3 from both sides. So we have 2x equals the natural log of 7 minus 3. Then we just divide by 2, divide by 2. That leaves us with x equals the natural log of 7 minus 3, all divided by 2. And that would be the answer to this equation. Solve 3 to the 1 minus 2x equals 4 to the x. Solution. So we have an exponential equation, and a lot of times when we have these types of equations, we'll try to write both sides using the same base. However, this time we have a 3 and a 4, so that doesn't appear to be a very easy option. So we have a couple choices, but all of them really involve taking the log of both sides. You could use log base 3, and that will make things a little bit easier. You can also use log base 4, and that will make things easier. Or you can just use the natural log and grind through it. Let's go ahead and use log base 3. Recall if you have log base b of b to the x, that's equal to x. So basically when the bases are the same, everything goes away, you just get x. So I chose 3 because this looks more complicated than this, but you could also use 4. So we'll take the log base 3 of the left-hand side, and that's equal to the log base 3 of the right-hand side. The notation gets some getting used to. Make sure you put the 3 in the correct place and stuff like that. It does take a lot of practice to get good at this. Let's examine our formula once again. So you see here, this is x, and so this is our x in the actual problem. So just like these cancel, so do these. So you're left with 1 minus 2x. That's equal to, here what you can do is you can use the power rule for logs to actually just bring down this exponent and put it in the front. So this is x log base 3 of 4. Okay, we're looking for x, so we need to get all of them on one side. So you could subtract this, but I don't want two negative signs, so I'm going to add the 2x to both sides. So we have x's all on one side together. So this is 1 equals 2x plus x log base 3 of 4. And now they're all together on one side. So now what we can do is factor out an x. So this is x parentheses 2 plus log base 3 of 4. Because this is being multiplied by x, what we can do now is by all of this rather, is we can divide by all of that. So 2 plus log base 3 of 4. Same thing over here, 2 plus log base 3 of 4. Boom. So x is equal to all of the stuff over here. Let me just write it again over here. So this is 1 over 2 plus log base 3 of 4. And so this would be the solution to this equation. Solve pi to the 1 minus x equals e to the x. Solution. So we have an exponential equation, and since it doesn't seem that we can make the bases the same in an easy way, let's go ahead and just take the natural log of both sides. So we have the natural log of pi to the 1 minus x, and that's equal to the natural log of e to the x. Now we're going to use a very powerful formula. It's called the power rule for logarithms. So if we have p to the natural log of x, that's the same thing as the natural log of x to the p. So our p here is this piece here. So notice you can just take the little p and put it in the front, which you did here. So take this and put it in the front. So this is 1 minus x times the natural log of pi. And that's equal to, here, this is a very powerful formula. If you have the natural log of e to the x, this is just x. So this goes away and you just get x. Okay, we're looking for x and it's trapped inside these parentheses and there's 1 over here. So let's start by distributing the natural log of pi. So 1 times the natural log of pi is just the natural log of pi. And then negative x times the natural log of pi is just negative x times the natural log of pi. And over here we have x. We're looking for x, so we should try to get all of the x's on one side by themselves. So we'll add x natural log pi plus x natural log pi. These go away, so we have the natural log of pi equal to x plus x natural log of pi. So now what we can do is we can factor out the x from both terms on the right-hand side. So we have the natural log of pi equals x parentheses, and this is 1 plus the natural log of pi. So now we can just divide both sides by 1 plus natural log pi over, and then 1 plus natural log pi. Boom, these go away. And we're basically left with all of this as our solution. So x is equal to the natural log of pi, what a cool answer, over 1 plus the natural log of pi. That would be the solution to our equation. Solve the natural log of x equals 1. Solution. We're going to use a very powerful formula to do this problem. It basically says if you have e to the natural log of x, this is equal to x. This is super useful to know. So I'll start by writing down the original equation one more time. This is the natural log of the natural log of x, and it's equal to 1. So we're missing the e here. So what we'll do is we'll put 1 here, and we'll put 1 here. This process is called exponentiation. We are exponentiating both sides of this equation. So now you see that this whole piece here is our x. See how it matches the formula. So just like these go away and you get x, these go away and you get the natural log of x, and that's equal to e to the 1, which is e. Then we just repeat the process. We do it again. We exponentiate. These go away, and so we get x equals e to the e. And this would be the solution to this equation. Solve 3 to the 2x plus 3 to the x minus 2 equals 0. Solution. So this is actually a quadratic equation in 3 to the x. And the reason I know that is because I've done problems kind of like this one in the past. Whenever you have something like this where you have a 2x and an x and the bases are the same, you can write it as a quadratic equation. In fact, if you wanted to, you could write it as 3 to the x squared, right? That's because properties of exponents say that 2 times x is 2x, plus 3 to the x minus 2 equals 0. Now you don't really have to make a substitution to do this problem, but let's go ahead and do it just to add a little bit of clarity. So I'm going to let u be equal to 3 to the x. So this becomes u squared plus u minus 2 equals 0. So you can always do this when you have these types of equations that turn into quadratics. Okay, this should factor. Let's try to do it. So we have parentheses u, and then this is equal to 0. So we need two numbers that multiply to 2, so obviously 1 and 2. But they have to multiply to negative 2 and add to positive 1. So I'm thinking make the 1 negative and the 2 positive. Let's check that. U times u is u squared. The inside piece here gives you 2u. The outside piece gives you negative u. When you add the inside and the outside, 2u plus negative u, you get 1u, which is the middle piece. And 2 times negative 1 is negative 2. So everything looks good. So from this, we set each piece equal to 0. U plus 2 equals 0, or u minus 1 equals 0. So u equals negative 2, and then here u is equal to 1. And so now we have to go back to our original variable, which is x. So u is equal to 3 to the x. So this is 3 to the x equals negative 2, and this is 3 to the x equals 1. So now we have to solve for x. So there's a couple ways to do this, but first realize that this first one here is impossible, right? That doesn't work because 3 to the x is always positive. If you think about the graph of 3 to the x, it looks something like this. This is the graph of y equals 3 to the x. And you see that it's always greater than 0, right? This is the x-axis, this is the y-axis. So it's always above, it's always up here, so it's always positive. So it can't be negative. So the only one we have to solve is this one. And to solve this one, you can guess, right? The answer is 0 because 3 to the 0 is 1. Or if you like, you can take the natural log of both sides. When you do that, what you can do is now you can bring down the x. So you get x ln 3. That's the power rule for logs. The natural log of 1 is 0. Then divide by the natural log of 3. 0 over a non-zero number is 0, so we get 0 as the solution. Again, another way is to look at it and say, hey, wait a minute, x has to be 0 because 3 to the 0 is equal to 1. Boom. This is the solution. Solve 7 times e to the x minus e to the 2x equals 12. Solution. So in this problem, we have e to the x and we have e to the 2x. The trick is to notice that you can think of e to the 2x as e to the x quantity squared. So you can think of this as a quadratic equation in e to the x. So because we typically set quadratic equations equal to 0 to solve them, let's start by doing that. So we'll subtract 12 from both sides. These cancel, so we have 7e to the x minus e to the 2x minus 12, and that's equal to 0. Okay, so let's go ahead and write it in a descending order. Let's write it like this: negative e to the 2x plus 7e to the x minus 12 equals 0. Basically, I just flip these two. That way this one comes first because that's really the squared term. And let's also now multiply by negative 1 just to get rid of that negative so it's easier to think about. So we'll just go through and we'll just switch all the signs. So this is e to the 2x minus 7 e to the x plus 12, and that's equal to 0. And we should be able to factor this, I think. Let's try. So we know that we need an e to the 2x here. So we can do e to the x times e to the x. And the reason this works is when you multiply e to the x times e to the x, because the bases are the same, they're both e's, you add the exponents. X plus x is 2x. Boom, so it totally checks. Now we just need two numbers that multiply to 12. So 3 and 4 would work, and add to -7. So let's just make them negative so that everything works out really nice. So now we have a product equal to 0, so we can set each factor equal to 0. E to the x minus 3 equals 0. E to the x minus 4 equals 0. We add 3 here, so we get e to the x equals 3. Add 4 here, we get e to the x equals 4. And because we're looking for x, we can simply take the natural log of both sides like this. And we can use our powerful formula. These go away. So we get x equals ln 3. Boom, it's one of the answers. Do the same thing here. Natural log of e to the x equals the natural log of 4. Boom, these go away. So we get x equals the natural log of 4. Really a nice problem, and honestly, once you do this once, you learn to recognize it. You'll know, because whenever you see something like this with an e to the x and an e to the 2x, just know that you want to write it like this, right? Your goal is to get it somewhere like this, and then attempt to factor it. If you can't factor it, you can always use the quadratic formula. Solve e to the ax equals c times e to the bx, where a is not equal to b. Let's go ahead and try to solve for x. So I'm going to start by writing down the equation again. E to the ax equals, I'm going to leave some room here, c e to the bx. And the reason I left some room here is because I want to use this formula. You have ln of e to the x, that's equal to x. This is a very, very powerful formula. So what we'll do here is we'll take the natural log of both sides so that we can use this formula. So we have the natural log. Well, I guess I could have done it up here. That was the whole point of leaving some room. There we go. And I'm going to insert parentheses here just for clarity. You could put them here as well, but it's really not necessary. So I'm going to go ahead and undo that. So you see these go away just like they do in the formula. So we're left with ax equals. Now here we can't quite use the formula because of the c. So instead what we're going to do is we're going to use a different formula. We have c times e to the bx. So the multiplication should make you think of something called the product rule. The product rule says if you have the natural log of, I'll use u and v, u times v, the multiplication turns into addition. This is the natural log of u plus the natural log of v. So this becomes the natural log of c plus the natural log of e to the bx. Let's keep going. This is ax equals the natural log of c. Here we can use the formula. So we just get plus bx. So we have to solve for x. We have an x over here and an x over here. So let's go ahead and put all of the x's together on one side. We can do that by subtracting bx and subtracting bx. These go away, so we have ax minus bx, and that's equal to the natural log of c. Because we have an x on each term here, we can factor out an x. So this is x parentheses a minus b, and that's equal to the natural log of c. Since the x is being multiplied by a minus b, right, there is a times here. To solve for x, we simply divide by a minus b. And perhaps this is the part where we need to realize that a is not equal to b. Otherwise, we would be dividing by 0. So x is equal to the natural log of c over a minus b. And that would be the answer to this equation. Solve e to the x equals 2. Solution. This is a scary looking problem, but it shouldn't be too difficult. We're going to use this super powerful formula, which says we have the natural log of e to the x. That is equal to x. This is super useful to know. So now what we'll do is we'll basically take the natural log of both sides of this equation. So we have the natural log of e to the x equals the natural log of 2. And so if you look at this formula, you'll notice that basically this here is our x. So this is going to go away, and we're left with e to the x equals the natural log of 2. And again, we're looking for x, so now we will just repeat the process. We'll take the natural log of both sides again. That's equal to the natural log. And I'm going to go ahead and insert parentheses here just to add an extra level of clarity. Note that you can put them here as well, but people usually don't. These go away, and so we have x equals the natural log of 2. And that would be the solution to this equation. Solve 2 times the natural log of x equals the natural log of 2 plus the natural log of 3x minus 4. Solution. So let's start by using some properties of logs so we can condense everything. So over here on the left, we have 2 times the natural log of x. Recall if you have a number, say p, times the natural log of x, what you can do with the p is you can bring it upstairs and write it as ln x to the p. This is called the power rule for logarithms. So we can write this as ln of x squared. This is equal to, over here we can use another formula. It says if you have the natural log of a plus the natural log of b, that's equal to the natural log of a times b. This one is called the product rule for logarithms. So here our a is 2 and our b is 3x minus 4. So this is the natural log of 2 times parentheses 3x minus 4. Okay, we're in a much better place now. So there's 2 ways to proceed. We can simply exponentiate both sides, or simply drop the logs, because whenever you have something like this, these must be the same. Let's go ahead and show some work. Recall that if you have e to the natural log of x, that's equal to x. This is a very, very powerful formula. So here we'll put an e, here we'll put an e. These go away, right? That's our x. So we have x squared equals, these go away. Let's go ahead and distribute. 2 times 3x is 6x. 2 times negative 4 is negative 8. Okay, now we have a quadratic equation. Whenever we have a quadratic equation and we're trying to solve it, as a general rule, you always want to set it equal to 0 and attempt to solve it. So we'll subtract 6x and add 8 to both sides. Just like that. Boom, boom. So we end up with x squared minus 6x plus 8, and that's equal to the number 0. Let's try to factor this. I'm pretty sure it will. So we can factor by guessing. So we'll write some parentheses like this, and we'll put an x here and an x here, because x times x is x squared. So now we need 2 numbers that multiply to 8 and add to negative 6. Well, 4 times 2 is equal to 8, and if they're both negative, they'll add to -6. So that should work. We set each piece equal to 0, and we can see that x is 4 or x is 2. But this is not the final solution. We need to check our answers because we have 2 logs. Also, when we brought up the 2 here at the beginning, we might have created an extra solution. So I'm going to go ahead and write down the original problem one more time. So 2 ln x equals natural log of 2 plus the natural log of 3x minus 4. And in order to check, we have to go back to this equation. It's really important to check when you have more than one log in an equation. So let's check 4. So if we check 4, we get 2 natural log of 4 equals natural log of 2 plus natural log. Let's see, 3 times 4 is 12. 12 minus 4 is 8. Okay, so we need to see if these are actually the same. Okay, we need to see if they're the same. So what we can do here is we can keep going. We can bring the 2 up. That's ln of 4 squared. And then here we can use the product rule for logs. 2 times 8, that's ln of 16. And that's correct. 4 squared is 16. Again, this is the product rule. I skipped a step here. It's ln 2 times 8, which is really ln of 16. So yeah, everything looks okay. So 4 is one of the answers. Let's check 2, see if 2 works. So checking 2, on the left-hand side, we'll have 2 ln 2. On the right-hand side, we have ln 2 plus, putting a 2 here for the x is going to give us 3 times 2, which is 6. 6 minus 4 is 2. So we have the natural log of 2 plus the natural log of 2, which means we have 2 of them. And so, wow, that also checks. So in this example, both of them were actually solutions. Sometimes it doesn't check, and if it doesn't check, that means it's not a solution. But in this case, they actually both worked, which is sometimes kind of unusual. So it's kind of cool to see an example where they both worked. Solve log base a of x plus log base a of x minus 2 equals log base a of x plus 4. Solution. So in this problem, we have 3 logarithms. So the natural thing to do is to try to combine them. So on the right-hand side, we have a single log, and over here we have 2 logs. We can easily combine these using something called the product rule. The product rule says if you have the log of, say, u plus the log of v, this is equal to the log of the product, so u times v. So here, this is our u, and this is our v. We basically just have the log base a of u times v, so it's x times x minus 2. And on the right-hand side, we simply have the log base a of x plus 4. Now we need to get rid of the log. So what we can do now is we can exponentiate. Recall if you have b to the log base b of x, that's just equal to x because the bases are the same. Here the base is a, so we'll exponentiate by putting an a here and putting an a here. And just like they cancel in the formula, they will cancel in our problem. So we have x parentheses x minus 2, and that's equal to x plus 4. Good stuff. Okay, we have to solve this, so let's go ahead and distribute the x. X times x is x squared. X times negative 2 is negative 2x. And this is equal to x plus 4. This is a quadratic equation. Whenever you have a quadratic equation, you should try to set it equal to 0 and solve. So we'll subtract x, subtract 4, subtract x, subtract 4. Boom, boom. So we end up with x squared minus, so let's see, minus 2x minus x is minus 3x. and then minus 4, and that's equal to 0. Let's attempt to factor this. I just know that usually when we have problems like this, they usually factor. It's very rare that you have a problem like this that doesn't factor. It happens, but it's rare. So we have an x here, and we have an x here. We need to multiply to 4 and add to negative 3. So 4 and 1 multiply to 4, and if we make the 4 negative and the 1 positive, it'll work out. Let's double check. X times x is x squared. If you do the inside, you get x. If you do the outside, you get negative 4x. When you add the inside and the outside, you get the middle term. You see negative 4x plus x is negative 3x. And 1 times negative 4 is negative 4. So we set each piece equal to 0, and as you can see, we get two possible answers, negative 1 and 4. Whenever you have an equation with more than one log, it's really, really important to check your answers. In this case, negative 1 cannot be an answer because right away we see if we were to plug it back in, we would get the log base a of negative 1. And that's a big no because you cannot take the log of a negative number. The domain of the logarithm consists of positive numbers only. So the last thing we have to check is the number 4. I don't know if it's going to work because I have not done this problem, so let's go ahead and try it. So let's put a 4 everywhere in, we see an x. And it's important that you use the original equation when you're checking. Then here we have log base a. 4 minus 2 is going to give us 2. And this should be equal to log of 4 plus 4 is 8, right? Because x is 4. And here we use the product rule, log base a. 4 times 2 is 8. And that's equal to log base a of 8. So everything looks okay. So the answer to this equation is x equals 4.